Hi, I'm Abby.
And I'm Alec. We are Team 18127 of All Hands on Tech, a fifth year FTC team from Lake Oswego, Oregon. Our goal is to spread interest in robotics and increase youth interaction with STEM. So, what is build? We design, prototype, and test build the robot, which we use for the competition, and we have to understand how the robot works and what it does. We have to strategize for points to prioritize and efficiently create a robot that delivers the goal of the competition.
In this slideshow, we will address the chassis, the different kinds, and the pros and cons of each. The assemblies, like intake, delivery, and specialty assemblies specifically designed for the season. Electronics, so like control electronics, wiring, programming, basically the guts of the robot, and the parts and tools we most commonly use.
Okay, so the first one is the chassis. The first main one is the two motor chassis. It's very simple and basic to build, but it's underpowered since it only has two motors. It's direct driven, which isn't good for the motors, and it's bad. It doesn't have good maneuverability. The second chassis, the four-wheel chassis, has good maneuverability and room, but can be pushed around easily, and it's heavy and not very good pushing. For the third one, the six-wheel chassis, it's very stable, great acceleration, good for rough terrain, but uses a lot of power from the batteries, and it's large. The eight-wheel chassis combines the stability of the six-wheel chassis and the agility of the four-wheel. It's super stable and amazing grip and acceleration. The cons are it's very large and it's hard to power all of them, along with it draining a lot of power. The X-Drive chassis has good maneuverability, agility, and acceleration, ideal for like strafing, but it uses direct drive. It has awkward wheel placement, as you can see in the corners, and can be pushed around easily. The Tank Drive chassis has amazing grip, pushing power, and traversing terrain similar to the 8 and 6-wheel chassis, but it doesn't have good maneuverability and is slow, complex, and treads prone to break and falling off. It can't strafe either. The Kiwi chassis is the smallest, really small chassis. It's omnidirectional and it only uses three motors. But you can't really fit that many features and it can't go over rough terrain.
All right, section 2 is the assemblies. So the intake, the delivery, and assembly is built specifically to tackle this season's challenges. Assemblies generally need to be consistent, reliable, controllable, and efficient. They change every year, but you will likely be designing and building something to grab game elements and something to place them, and something to move them in between the two assemblies. So that's like 3 parts that you have to design for. This robot is from ACMA's 2020 to 2021 season, sorry. The intake is currently grabbing the game element, in this case a foam ring, to push into the robot. The delivery will then shoot the ring into the goal at the end of the field. The area in between the intake and delivery mechanisms is helping the ring move through the robot smoothly. For them, this is a ring conveyor. This is different for each season. The specialty assembly is basically just a claw that grabs onto the game element. This game element is only used once or twice in the game, which is why the claw is taking up very little space on the chassis.
Okay, number 3, the electronics. This is a very basic rundown of common wiring system. It changes for every bot as there's many different assemblies that we talked about earlier and different drives. These are the control components of the robot. The driver hub is what we download the code to, where the programmers can upload the code to, so we can run the robot and connect to the gamepad. Yeah. The control hub manages all the wires and connects the driver hub via Bluetooth, so it knows which one the motors are. The gamepad is what we control the robot. It is the controller and the console thing. And here's an electronics reference sheet that can be found on the Rev Robotics website. This is useful for first or second time wiring, just to make sure that everything is in its proper place. Now, the wiring of the robot serves two primary purposes: to provide power that makes it turn on, and to provide the line of communication to the robot's control system. This is important so that you are able to program it. While building, however, it is important to think about where you want to put all of the wires, because wire management is a big part of the robot. We have to run into the wire management problem because we built the chassis without really thinking about where the cables would run through, and it's a big mess.
All right, section 4 is the parts. So this is manufacturers and tools. This section is about game legal manufacturers and tools you should have in your toolkit for building. So Game Manual 0 outlines several manufacturing building companies. This is just a list of everything we'll cover in the next 2 slides, as well as some raw material companies such as Online Metals and E-Plastics. So these are really good for specialty parts. Now, 2 main build systems that we have here are robotics and GoBuilda. Oh boy, that is okay. Most build systems have different hole patterns, but all serve the same purpose. We use GoBuilda just because that's what the team that founded us had, and so we had most of those parts, but I've seen teams use Rev, as well as Actibotics, Matrix, Studica, Tektronix, the other one that I can't see. I love this, okay. But they all really just serve the same purpose. Now, it's important to know that the build systems may have one of 2 different measurement systems, which is metric and imperial. And so that's important when buying your tools, because you don't want to get metric tools and then realize that your build system needs imperial screws. That's a thing that happens sometimes. And then the list below is just stuff I've condensed out of our toolbox. The slide wasn't big enough, so I put it on a different slide. I'm so good at this. Okay. Hex keys. They come in a T handle and an L handle. The T handle helps apply force to drive a screw in or get a stripped one out. The L handle fits into smaller spaces, but then like you have a regular like handle and that's more comfortable to use. The ball tip allows for more angles at screwing or unscrewing something, and a straight tip allows more force. So if you really had a stripped screw that's very much stuck in your chassis, a T handle with a straight tip is definitely going to get that out. Wrenches. This is for nuts to keep the screws in the robot when there's nothing else to screw into. So that's very important. And a metal file. To be competition legal, you cannot have sharp edges, which includes the metal chassis parts. So you do have to, depending on the build system, you will have to file down the corners just to make them not sharp, I guess, you know. Calipers, tape, both electrical and painters and zip ties are unnecessary but helpful, as well as needle nose pliers, hemostats, which are like, if you took tweezers and made them better and easier to like hold on to screws with, wire cutters, and either a ball peen or a dead blow hammer. These 2 hammers help you not dent the metal parts because they're made of the chassis build systems are made of aluminum, and so they're really easy to dent. And so ball peen and a dead blow hammer help us to not damage them too much. Loctite is also not needed, but very helpful because it stops screws from falling out. If you are going to buy it, buy purple and blue, because red and green will definitely make sure the screws are in there forever. Bright red tacky grease from Andy Mark. We call it strawberry jam, but basically it helps gears turn. If you're going to buy it, our team puts it in a syringe, and just to like make it easier to apply, it's really hard to get off hands. So I would recommend this syringe. And then these are just helpful links that can be used as a reference that I also use to help build this because it's not my first year. It's been a while. And if you have any questions, you can contact us at any of these fun little links, or unmute and ask, or just type it in the chat.